Yep, we're good.
Okay. Hi, everyone. My name is Damon Smith, and today we're going to be doing a short introduction to script injection attacks, also known as cross-site scripting, XSS, whatever you want to call it. How many people have actually heard of this attack before? So at least 50% of you, that's pretty good. How many people think that they have a pretty good grasp on what it is? Okay. How many people think that they can actually execute this attack themselves, and this presentation will provide no added value? Jay, go put your hand up. Okay, well, for those people, we're going to allow a little challenge during this presentation to keep you interested. So if you ever get bored of this presentation, go ahead and open this link. Go ahead and finish it for you. It was an S, right?
Yeah.
I think it was an S. And you will be presented with that lovely site over there. On that website, you will have the opportunity to create an account and start doing stuff. The first person who can cause a alert box to pop up on that screen wins Monster Energy, 5-Hour Energy, Oreos, and Butterfingers. No, I actually bought all of this stuff like 5 minutes ago.
So how are we going to tell who actually successfully did it?
You probably want to ensure that your name is included in the payload, so that way we'll actually be able to give you your prize. And your name can't be Jagor, because that would be unfair for everyone. So that page is auto-refreshing every 5 seconds. So in theory, as soon as your payload goes through, we should see it just pop up there. Try not to keep it vulgar and don't do anything terrible, guys, because, you know, it's not very nice. So be cool, and we'll all have a good time. And if I don't see that when it pops up, someone just shout out and say, oh, look, someone won, and I'll go look at it, and we'll get the prizes straightened out. So back to the subject at hand. Who am I, and why on earth would you spend the next 45 to 50 minutes listening to me? I am senior CS major. How many CS majors in the house? Represent? Okay, we can overpower them. I have 10 years of unofficial offensive security experience, 2 years of official offensive security experience, working at 2 different companies in town, neither of which I'm representing today, which brings me to my disclaimer. While I might be wearing a t-shirt that represents TrustWave Spider Labs, everything I say today is solely my own creation, my own property, and in no way represents my employer's thoughts, feelings, opinions, fears, hopes, or dreams. So it's all me, not my employer.
What about ComSoc?
And it also doesn't represent whatever ComSoc says, thinks, or does. And another important disclaimer that we include in all of our presentations. The purpose of showing you this attack is to teach you how to present them. Most sites have already had extensive testing against cross-site scripting, and there's a decent chance that sites like Facebook and Google either won't be vulnerable or it'll be arbitrarily difficult to find vulnerabilities. So basically just don't do this anywhere except training applications that you yourself are running, or for instance our little lab application over there. So yeah, that's my little spiel there. It is unlegal and unethical. Did I say unlegal? It's illegal and unethical to attack someone's website without their prior consent, and I'm very serious about this, guys. It's not cool. Don't do it. You'll get arrested. Jagor will arrest you. By the way, that's Jagor I keep shouting out to. He's a representative of the UT Information Security Office, so it's his job to arrest you when you do bad stuff. Is that accurate?
Kind of.
Yeah, I was close enough. So let's start talking about the actual hacks now. What does XSS represent? Well, to start, we need to explain a little bit about the hierarchy of trust that takes place on the internet. Most people, when they're browsing the web, have sort of an inherent sense of which sites they should visit and which sites they should avoid. This is my own personal hierarchy that I've constructed for demonstration purposes. At the very top, the most trusted of trusted websites is Google. It's pretty much God. You know, if you can't trust Google, then the entire internet just falls apart. After that, you put a fair amount of trust in educational and government-owned domains because they are very unlikely to be harboring attack traffic. It's possible, but generally speaking, they're trusted. Coming immediately afterwards are websites that I personally know who maintains the content and who is responsible for ensuring the security of those websites, like my bank, Facebook, and Twitter. After that are unknown websites that are in popular top-level domains, like where it's not necessarily an unknown domain name, but maybe I don't know who's generating the content, like a blog on Blogspot, or some random widgets.com website. They're pretty reasonably trusted, but at the same time, you don't want to necessarily blindly charge into them clicking every link you see. And it really goes downhill from there when you start seeing things like .ru, .info, .cn. Not to discriminate against certain domain names, but my legit site .ru.info is probably not something many of us would ever go to on purpose. And then at the very bottom of the hierarchy, you have very obvious attack websites, such as a randomly generated string of numbers and letters .info. Like, that's pretty obviously not something that is hosting legitimate content, and you should just stay away. So this trust model is all well and good, and it does a pretty decent job of keeping us all safe on the net. But what if scripts from attack websites could be included on trusted websites and execute in the context of that trusted domain? That is what we call script injection or cross-site scripting. It's all about...
Can you move over a little bit? Thank you.
Okay, it's all about abusing the trust of users that are visiting the website. The Wikipedia definition is up there. I'm not going to read it to you because that would be a waste of everyone's time. But basically what cross-site scripting allows you to do is run your own untrusted code in the context of a more trusted domain, like CNN.com, BankOfAmerica.com, whatever. The de facto example that everyone thinks of when I say cross-site scripting is something as simple as setting your username to that little string down there, which is opening a script tag, popping up an alert box that says hacked, and closing the script tag. How many people are generally familiar with HTML syntax? Like, is this making sense to people, what I'm writing down there? You have your open tag, and then you have the content of the tag, and then you close it. And in this case, it's a script tag saying that this is JavaScript, I want you to execute it, and the function that we're executing is called alert, and we are passing the value hacked to that alert, which just pops up a little dialog box that says hacked on your screen. Here's a notable example of what an alert box might look like on a website that you would injected a cross-site scripting payload on. I don't know if anyone's familiar with that website, but it's a good one. I go there a lot. It's pretty nice. It's actually the SigSac website, and just a note, I didn't actually hack it. I just doctored a screenshot that included it. So don't get mad at me, SigSac people. There are two important classes of cross-site scripting that we're concerned with. And depending on what type of attack you're dealing with, the level of risk associated with it can be significantly reduced. The main two types that we're concerned with are reflected and stored cross-site scripts. An example of a reflected cross-site script is when you visit a page, passing that page certain parameters, and those parameters are then sent back to you. For instance, if you went to a search page, typed in pictures of funny cats, and the resulting page says, I couldn't find any matches for pictures of funny cats, you have the potential for a cross-site scripting vulnerability. Anytime user input is being sent back in the response from a website, there is potential for a cross-site scripting flaw, assuming there is not proper validation and filtering, which we'll talk about later. Those are not tremendously interesting or dangerous because it requires a user to click on a link that you supply, for instance, in a phishing email or on another website. So there's a little bit of an added complexity towards exploiting those attacks, but stored injections are a lot more dangerous. The reason is, if I join a forum and put that as my username, every single page that contains my username on it will immediately execute that script. The user doesn't have to click on anything, the user doesn't have to visit any untrusted links. All they're doing is browsing a website that they already trust, and my code is running in the background. There are some pretty large companies that have fallen victim to XSS attacks in the past, and I've included a few notable examples here. I don't know if any of you recognize that company. It's a little Silicon Valley startup called Google. They do like searches or something. And this is the Google Accounts page, which by executing payload on this page, I'm actually able to gain access to your entire Google account. Now, I didn't find this flaw. I just happened to find a screenshot that someone had submitted documenting this flaw on the internet. But the fact that this flaw ever existed is frankly a little bit terrifying, because your Google account for many people is your entire life. It's synced with your phone, it's your contacts, it's all that. And this basically allows me to steal the whole thing. Another notable example, eBay had a pretty prominent cross-site scripting flaw. So I could, run script to force you to make transactions on eBay that you didn't want to, all sorts of nasty stuff. Another great example is Facebook. There was actually a cross-site scripting flaw in Facebook where just by sending someone a little chat notification message, you could execute code on their machine. Pretty scary stuff. And finally, Twitter. Twitter is like a hotbed for cross-site scripting flaws. I don't know like what they're doing wrong, but it seems like almost every week they announce a new cross-site scripting flaw. And cross-site scripting flaws on Twitter are especially interesting because if they occur in the context of sending a tweet, you can send a tweet with the cross-site scripting flaw, which in turn executes a script and causes anyone that views it to send out that same tweet. So I don't know if any of you are familiar with, what was it, the Sammy worm on MySpace that was spreading between people's profiles. That was a cross-site scripting flaw, and it pretty much brought down the entire network for an extended period. And similar flaws are still found today in major websites like Twitter. So how do these people find these flaws? Well, the easiest way and the quickest way to just go ahead and hit pay dirt is using automated tools. Pictured there is a tool called Burp. This is the professional edition that I pictured, and it basically walks through a website, finding all of the places where users can supply data, the login field, the search field, and test them to see if they're vulnerable to cross-site scripting. Unfortunately, it costs money. It's about $300 a year, so it's not terrible, but it's also not free. It is considered the gold standard in the industry, so pretty much everyone that's serious about this stuff uses it. But there are some free and open source alternatives that I've included just for completeness sake. While Burp is generally pretty good at detecting certain types of cross-site scripting flaws, it is abysmal at detecting other types, so it's certainly not a catch-all and shouldn't be relied on exclusively. In addition to automated tools, there is manual testing. And I've basically thrown up a 1, 2, 3-step methodology for conducting manual testing, which is parameter enumeration. Parameter enumeration, you basically find every place that you as a user can put something into the application that at some other point comes back out of the application. Pretty simple. Then in each one of those instances, you're looking for what's called a reflexive value, which is something that you put in that is later displayed to either yourself or someone else. And then finally, once you've found your reflexive parameters, you have to actually see if they're doing any input validation on those parameters. We'll cover input validation in just a minute. So one of the common defenses against cross-site scripting is filtering input. So of course, it was obligatory that I include a slide on filter evasion. So let's say you encounter a website where the script tag is just straight up disallowed, it's filtered. You would think, oh, maybe that's mitigated cross-site scripting and there's no risk here. In fact, that is simply not the case because there are many tags that are capable of executing cross-site scripting payload, such as this image tag that includes a JavaScript function. That will still execute the payload and doesn't include any calls to any use of the script tag. What's that?
We're just going to wait for it to pop up now that you told us that.
Over there? I mean, maybe that one works, maybe it doesn't. I guess someone will have to find out. Maybe they filtered the JavaScript keyword entirely, so you think that might be an effective defense. Wrong, because you can actually break up the JavaScript keyword by injecting other characters that will be removed when they're parsed. For instance, that is an embedded new line character, and in a lot of browsers, this will still actually execute the cross-site scripting payload, and as you can plainly see, it does not include the word JavaScript. Finally, maybe they have a really top-notch filtering system. They're just getting everything right, except they're not executing it recursively. This is actually one of my favorite bypasses. You can actually use their own filter against them. If they are removing all instances of the script tag, you put a script tag in the middle of your script tag, so that way when they remove the first script tag, the second script tag gets completed, and hilarity ensues. I call this the yo dog attack. So let's say that they just aim to cover all their bases and they filter the left angle brace and right angle brace. It seems like it wouldn't be possible to inject a cross-site scripting payload at that point, right? Wrong again. You can actually inject attributes into an existing tag. So let's say you were allowed to specify a link to an image file on a website, maybe a blog or something. You would be able to put in a link to a file which doesn't exist, close the source tag with a little quotation mark, and then you can add this additional attribute called onError, which means if I'm unable to load this file, execute this JavaScript instead. So once again, even though they've done a lot of work on their filtering, they're still getting owned. And OWASP actually maintains a very comprehensive list of filter bypassing techniques. So you should probably all look at that if you're ever experimenting with XSS flaws. So far I've showed you what XSS is, how to cause XSS to happen on a variety of websites, but alert boxes are kind of stupid. Like, that's not real hacking. So what can we actually do with this? Enter Beef, the browser exploitation framework, and frankly one of the most terrifying tools I've ever seen. It was actually designed by a fellow at TrustWave, but that's not necessarily the most interesting thing about it. What's much more interesting is what it can do. Simply by injecting a link to Beef into an application, which I'll show you in a minute how this is done, I can get all of those capabilities, and that list is maybe a tenth of what it actually offers you. You'll notice that things like setting up keyloggers, getting stored credentials, exploiting other systems on the local network, making telephone calls on mobile devices, all of these things are pretty terrible, but the one that I've highlighted that I personally find the most interesting is the ability to launch Java payloads. So, can we use cross-site scripting to get shell on a machine? The simple answer is yes. Yes, we can, because Java. I don't know if any of you follow Java security, but it's really bad. I actually just looked today a list of known exploitable vulnerabilities on a reasonably recent version of Java, and with 10 vulnerabilities per page, there were 5 pages, so 50 vulnerabilities rated critical, as in like this is the worst possible thing that can happen on a reasonably recent version of Java, and new ones are discovered pretty much every day. I mean, it's unreal. You've all been annoyed frequently at how frequently Java updates, always asking you to install the ass toolbar, all that garbage. And this is why. They have a lot of security problems. Another slightly interesting way to get shell on machines, and the one that I'll be demoing today, is the fact that I can use Beef with a module for Metasploit called Browser Autopwn. And what Browser Autopwn does is it basically sets up a web server, and I can use Beef to force people to go to that web server. And whenever you visit that web server, it checks to see what browser you're running, what operating system you're running, and a few other things, and basically launches every known attack against your browser until one of them works. And they pretty much always work. Because as that statistic points out, 95% of people just don't care enough to update their Java. And with that said, I'm going to provide you guys with a little bit of demo enjoyment. Has anyone had any success over there?
Someone cleared the database, it looks like.
Yeah, it looks like someone did clear the database. GG, folks. I need to change this display to mirrored, which is non-trivial. Give me just a second. Hide all that stuff.
I haven't done it yet.
Yeah, don't clear the database, guys. It's not cool.
So there's a SQL injection too in this app?
There is a lot of stuff in this app, which is why it's not running on one of my servers. It's actually running on Google Apps, or App Host, or App Engine, whatever it's called. Give me just 1 second, guys. I'm mirroring my displays. And that's not. Oh, so where do I mirror displays? Does anyone see it? Does anyone know how to mirror display on this thing? Ah, there we go. Okay. Sorry about that short delay, guys. I am not very well versed in Mac usage. So it looks like they're mirrored, so we can go ahead and move into our VM setups, maybe. So here we have a Kali VM, which I don't know the password to apparently, which is a standard penetration testing distribution. The sole purpose of this particular Linux distribution is to launch attacks, and it does a very good job at that. It comes preloaded with most of the tools that you'll want for any kind of attack you're looking to execute. This is going to be our attacker's machine. Alongside of it, we have a pretty likely combination of components. Windows XP Professional, Service Pack 3 with Internet Explorer 7. I actually looked up statistics. I think Ars Technica published them, and this is the most likely browser combination for a corporation to have today, which is pretty sad, honestly.
Yeah.
Oh! Is that you?
Yeah.
Good job.
Yeah, I did it
On your Wow. That is pretty good. Well, one prize to
I'll take them.
Congratulations. Maybe you will share your payload that you used.
I did the,
Yeah.
afterwards or right now?
Zoom was here right now. Is anyone curious?
Show.
Yeah, let's show it
I
off.
use the on-air one.
Very good. Yeah, that's.
Until the very end to show it.
Yeah, we'll wait till the very end. We'll keep the suspense.
Clear the database maybe.
Does anyone want these two? Because I really just want the candy.
Oh, are we trying to keep it going?
I got it.
Oh, you got it? Okay.
Yeah.
So this is our victim. This is our attacker. And then over here, I have an additional system that's just serving as a web server, so it's not tremendously interesting. I'm running an instance of that same application here on my VM setup. So let me just get into it. This is a Google product, by the way. Oh, I accidentally left my payload sitting there. Let me get rid of that so that this is actually fair. Oh, I hate Internet Explorer. So get rid of those. Okay, so now we have a fresh copy, more or less. And I actually have the payload saved right over here. And this one is probably a little bit more complicated than the ones that we expected you to use for the contest. What this one is actually doing, oh, that's really small.
Command plus plus.
Oh, we're zooming. We're zooming. Oh, look at that. Look at that. Oh, that's actually kind of hard to read. So what this is doing, it's actually using the image source on error technique, as we just saw successfully exploited. So I'm linking to example.com, which, as you may know, is a testing domain, so there's obviously no files on it. So not here.jpg is not going to be there, or not there.jpg, not here, whatever. And the on error function that we're doing, what this is doing is it's declaring a variable called s. And that variable is actually being assigned as a script tag that's being appended to the document. We're defining the type of s to be text JavaScript. We're letting it run asynchronously so that it won't block the web page while it's running. We are setting the source to be, and here is the address of our attacking machine. That will hook.javascript. And then finally, we are appending that script tag to the document head. So this is our payload that we're going to be using for fun and profit today. So let me just copy that, come over to our attacker, go ahead and put in that payload. There it is.
Ooh.
Someone else.
Oh, nice. Who's that? Very impressive. Nice job, guys. I really did not expect more than one person to get it, honestly, so this is pretty good. So, that payload that I just copied, we are now pasting. It's doing the same thing that it was a minute ago. So I'm going to go ahead and submit that to the page. And if we come back to the home, there you'll see an image that isn't loading, which in this case is actually a good thing. And now I'm going to go ahead and visit this page on our victim browser, and he sees the same thing. And now I'm going to log into the beef, well, actually, let me show you the beef console really quick. You can see down here at the bottom, I'm assuming, can people read that kind of? I mean, you don't have to see all of the minute details, but basically, we've now hooked two browsers. One of them is Firefox running on Linux, which is actually the attacker's machine, which is kind of ironic that he attacked himself accidentally. But we also hooked this little IE7 browser running on Windows XP, which is our intended victim. So we're going to go ahead and log into Beef, which is the tool that we're using to run all these attacks. And you'll see right here we have two browsers that are listed as online. And this is the Windows 1 running IE, so it's obviously the one that we're most interested in. And let's see, what can we do to this guy?
Everything.
Yeah, there are literally hundreds of these attacks that we can execute. It's just ridiculous.
Hacking wizard.
Let's try creating a prompt dialog. Just see what happens. See if he does it. And it generally, it's asynchronous, so it's going to take it a little bit of time to process. Hopefully it will eventually process. Did I actually click execute? Yeah, I did. So, yeah, it has executed the instructions and the prompt. Oh, scripted window to ask you for information. Well, forget that one. We're not going to use prompt because I guess prompt causes a warning to pop up. So let's do something that doesn't cause a warning. Let's just do an alert dialog. There. That'll show him. Alert. There we go. So you saw that happen asynchronously, which is kind of cool in its own, but the fact that I'm not actually injecting into the website, but controlling it from this little console here is pretty cool as well.
And then, so if you If you were to do that with the view tool, would everyone on that homepage see that message?
Nope, only that one browser, which is even better. That's actually a great point, and I'm glad you brought that up. The fact that I'm injecting these scripts, but as you can see, I'm still viewing this page on my machine, but those pop-ups aren't coming to me. So I am specifically targeting individual machines, and you can hold down, or you can select a multitude of machines if you really want to. But in this instance, I'm really just, for demonstration, attacking this one machine. So let me get to the actual meat of what we're trying to do today. Oh, by the way, taking pictures from the webcam. I don't know if y'all can read that one, but that's a pretty funny one. Because, Java and Flash all have access to your webcam. So make sure you put a little piece of electrical tape over it. So what I'm going to do right now, oh wait, actually I'm not doing redirect. I'm going to do a transparent iframe, which is under, there's so many options that I actually have trouble finding one. Oh, invisible iframe, that's the one we're looking for. So I'm going to inject an invisible iframe. How many of you actually know what an iframe is?
Isn't it?
So effectively what an iframe is, it's a little window in your website that allows you to include another website. It's kind of hard to explain. So say you have a navigation bar at the top and the content of the page at the bottom. Those could be rendered in separate iframes. So that way, when you're browsing on the bottom part, you're not affecting the top part.
You could kind of describe it as like a window to another web page.
Window to another web page. That man has it. There we go. So what we're going to do is inject one of those windows to another web page. The web page in question is going to be my local copy of Metasploit, and the window is going to be invisible. So this should be pretty funny. Actually, before I click go on that, I'm going to show you guys how I set up Metasploit to get this attack running. So I'm assuming a lot of you have used or at least heard of Metasploit before. If you haven't, we probably will be doing Electron this semester. We did one last semester. So definitely take a look into it in your free time. The module that we're going to use today is an auxiliary module called Browser Autopwn. So that's how you tell it to use a module. Can everyone see that all right? Is that kind of small? Okay.
It's a great name.
And we need to set a few options, like the lhost to my IP address. We're going to set the server port to port 80 because that's just a pretty normal thing to do for a web server. I'm going to set the URL path to be the root, and I'm pretty sure that's all we have to set up. One thing that's important to note about this attack is that it takes forever to get started. I'm actually not going to run the attack over here because I actually started it about 30 minutes ago in this tab so that you wouldn't have to wait 20 minutes for it to boot. So once it's going, you can exploit people, ad nauseum just forever with no additional load, but it takes forever to start the first time. So as you can see, it's already running here, and that's the URL that we want to deliver to our victim. So I'm going to go ahead and execute this, and we'll go ahead and watch the beef. So as you can see, we are sending the instructions to create that invisible iframe, and it looks like he executed the instructions, and here we go. He has connected to our hostile system, and we're sending him payloads, and one of them has already got us a shell. So let me see if I can stop this job. Like, if I let this thing run to a completion, I will have no less than 15 shells, which is just too much. You really only need one. So,
how many times you could exploit him?
yeah, I let it run for like 5 seconds, and I already got 3 shells before I could even tell it to stop.
Well, it depends what the privileges are on the shells. Because having one
They'll all have the
system
same
is
permissions. So let's go ahead and start interacting with one of these shells. Oops. And let's get user ID. In this case, it's Spider Labs because it's a VM I use for work. Don't tell anyone. And what is it called? System info, I think. Oh, what's the command, Jagor? Sysinfo? Yeah, there we go. So it's Windows XP. I'm running the Java interpreter because it was a Java exploit, and you get the computer name and all this other stuff. Let's see where we are. We are on the desktop, so let's go ahead and go into this confidential folder. Look at that. My social security number, credit card number, birthday, etc. Well, that's really convenient. Let's see what's in there. I've been owned. So we're browsing this guy's files. We're running code on his system. He's pretty much done for. Like we'll just go ahead and get a shell just for completeness sake.
Get system, bro.
And then we will shut down his computer. Let's see.
All right, give him a message.
So this guy's done for. In 30 seconds, his computer's restarting, and he can't even stop it.
Shut down Dash A! Shut down Dash A!
Yeah. You could stop it, but that's another thing for another lecture.
But if you're running Windows XP, you don't know how to write shutdown-A.
Exactly. So we are running our shell on his computer, and he didn't have to click yes on any alert boxes or click OK on any warning dialogues. He just went to a website that he trusted. In this case, he shouldn't have trusted it, but he went to a website that he trusted, and he got completely and utterly owned for it. Any questions about the demo? Anything? Any comments? Any people that are utterly terrified of using the internet now?
Does this thing expire? You have to set it up every once in a while, or does it just stay forever?
It expires as soon as you browse away from the web page. The XSS hook that we're talking about. There are ways to try to establish persistence. There's actually a whole tab called persistence. And these will attempt to get the hook to last after the user has left the web page, but they're kind of hit or miss. A lot of them just flat out don't work. Or if they do, like this one is called confirm close tab, which basically means when you try to browse away from the web page, it will ask, are you sure you want to browse away from this web page? And if you click yes, it'll just keep asking you over and over. So it really serves to do nothing except annoy the hell out of the person until they finally like Alt F4 their browser or something. So unless you are able to actually exploit like a Java vulnerability and run Meterpreter on their machine like we were just doing, then it'll go away. But if you actually are running Meterpreter on their machine, it's all over. Meterpreter has built-in persistence modules which will make it start on every reboot, set up rootkits. It gets really deep into your system, and there's really no getting into it.
There's a wonderful command called get system.
Yeah, there is a command called get system that will elevate your permissions. It's a whole mess. If someone's running executable code on your machine, it's not your machine anymore, it's theirs. So I think that does it for the demo. So let's get back to the presentation. I'm going to unmirror the displays, which you would think would be the inverse of mirroring, but this is a Mac, so. Come on, Mac, you can do it. I just want system preferences. Nope.
You're not allowed to have a system.
I guess you're using one display, bro.
There we go. Oh no, I totally got this under control, guys. Do forgive the momentary technical difficulties. And yay, we're back to normal. So let's go ahead and continue the slideshow. So, that was the demo. So I'm going to give a brief overview of what just happened to not only to help you remember and help you understand if you are clear, but also these slides are going to be published on our website. So if you want to sort of review what happened, this way you'll have a way to do that. The commands are not going to be included, but if you're really interested in learning how to do the actual commands and you don't remember them, you can either watch this on a YouTube video and try to figure out what they are, or you can just come by the office and ask us. So, what just happened? Assuming the demo worked, it did, someone just got owned. That someone was me, fortunately. And the first thing that I did was inject the XSS vector into the trusted website. In this case, it's our little test application. After that, the XSS vector itself will load a remote script from a completely different web server, the web server controlled by the attacker. The hostile script will hook into the browser and start sending it commands, which are controlled by me. And the hostile script commanded their browser to open an invisible iframe to a completely different website, which was running Metasploit browser autoclone. And Metasploit iterates through the known vulnerabilities, finds one that works, and bam, you've got shell on the machine. It actually has one of the exploits are successful, but in fact, it's like I said, like 15 of these exploits will actually be successful against that configuration. So let's talk a little bit about mitigation. As far as I'm concerned, there are two classes of people that might be concerned with mitigation: future and current application developers and users of applications. We're going to do developers first, and this is obligatory. We always have to cover mitigation if we're covering attacks. So, what do you do if you're developing a web application to reduce the probability of having a cross-site scripting flaw in your application?
Think.
Whitelist-based filtering. There are effectively two different schools of thought regarding filtering. There is a blacklist where you have this thing is not allowed, that thing is not allowed, etc. And there is a whitelist where you describe very specifically this thing is allowed and everything else is not allowed. The reason being, you are not omnipotent, you don't know the entire universe, and there's probably at least one tiny vector that you didn't think of that will probably get your app owned. Also, blacklist-based filters are very easily bypassed. We already had 2 people that bypassed one just a few minutes ago. 3 people now. That's even better. So yeah, don't use blacklist-based filtering. One great way to implement whitelist-based filtering. That's clever. That's clever. Is to actually implement regex or some other parsing mechanism for making sure that data you receive is in the expected format. Email addresses should not include angle braces and script tags, for instance. Usernames probably shouldn't include these things either. So just define a regex delineating exactly what you expect to be in a given field and throw out anything that doesn't meet those specifications. Another common mistake that application designers make is attempting to sanitize bad data or save it. For instance, if you've included a script tag in your email address, they'll just strip it out but try to use the rest of it. Don't do that. That is a huge information leak. Whenever I'm testing an application and I notice that they're using filtering based on a scheme like this, I can start throwing different strings at it to see exactly how their filtering mechanism is working. And as soon as I figure out how your filter works, it's trivial for me to bypass it. So by trying to sanitize this bad data, you are giving me information about your security filter. Like that's obviously bad practice. Finally, it's important to employ a defense in depth strategy. Defense in depth effectively means have your security at multiple layers within the application. You need to have security in front of the application. You need to have security behind the application. You need to have security in the application. That way, at each layer, there is an entirely new challenge for the attacker to bypass that given layer of security. Maybe your application presents a cross-site scripting flaw, but your web app firewall catches it and prevents exploitation. Then it really doesn't affect your application in the end. Yes, you should get it fixed, but at the very least, you're not having users calling and complaining that they got owned by visiting your website, which will ruin your business's reputation. Web app firewalls are a really great way to practice defense in depth strategies. Web app firewall is basically a little box. So the internet is here. The internet is here. Little Ethernet cable to the web app firewall. Ethernet cable to your web server. So it is intercepting all traffic from the untrusted zone, the internet, before it reaches your web application and checking for these attack strings. And if it sees any, it just drops the packet. So that's a great addition to a strong defense posture, but it is not a replacement for a secure application. Now, how do we mitigate these attacks if we're just a simple user and have no control over how secure or insecure an application is? You're all users of web applications, whether or not you realize it. Facebook is a web app, eBay is a web app. So this part might be important to you. The NoScript plugin. How many of you are familiar with NoScript at all? Okay, so we have a security conscious crowd out there, that's good. The NoScript plugin will basically disallow scripts unless you explicitly allow them. And it's available for most browsers, and it does great work. If you do not have scripts enabled on a particular web page, then this exploit is completely mitigated. There's simply no way for them to get these exploits to fire. And as long as you are very careful about which sites you allow scripts to run on, you should be fine. Basically, don't allow scripts to run on a site unless there's a compelling reason for it. Maybe it uses a lot of interactive content or AJAX and you need the scripts. But if you're like browsing, CNN.com, there's no reason to run scripts on that website. They're not doing anything with JavaScript that you need. So just disable scripts completely and you don't have to worry about cross-site scripting. Never click links. If they're sent to you in chat, do not click them. If they're sent to you in email, do not click them. If they are written on a piece of paper and given to you, do not. Well, that's different. But don't just type the address for the website you're trying to visit in your browser. If Bank of America sends you a link that says click here, don't do it. Just type in bankofamerica.com. This will more or less mitigate the so-called reflexive cross-site scripting flaws, where you actually have to click on a link. So it's common sense, but a lot of people don't really take it as seriously as they should. They're like, oh, this link points to bankofamerica.com. How bad could it be? And they click on it, and all their money's gone. Finally, it's important to use a good browser, not Internet Explorer, that has a strong sandbox, not Internet Explorer. Also be sure that your browser, Java installation, Flash installation, all plugins are completely and utterly up to date. If you ever see a Java please update me now dialog box and say no after this presentation, I will find you and I will hack your box, just for that. Oh, finally, one other, yeah.
Oh, no, go ahead.
Oh, okay.
Just don't install Java.
One other important consideration is, for instance, in my line of work, I do occasionally have to interact with very sketchy websites. As a security researcher, I sometimes have to troll like crazy Russian hacker forums that just have like all this shady stuff on them. And, you know, I can't be having that. You know, I don't want to get owned. So if you have to deal with untrusted websites, you know, that pirate ship website, for instance, run them in a VM. If you have never used a VM before, you should try it. It's pretty awesome. And the great thing about a VM is if they exploit your box, they're running in that limited context of that virtual machine. They don't have access to your confidential data stored on your computer. You know, they can't leverage other sites that you might have been logged into from the same browser session. Basically, just be smart and practice SafeNet.
You can also snapshot the VM and go back to a state before you ever went to any website.
Yeah, definitely. There are a lot of cool tricks involving VMs as far as preventing infection of this type, but figure them out. You're smart people. So, to wrap everything up, just a summary of what we've gone over. Script injection is a serious flaw with very serious consequences, both for the user and for the business hosting the app. These can include loss of reputation, civil liability in case someone gets owned because they went to your website, and you can actually have your own internal systems compromised because an externally facing application includes these flaws. For instance, an administrator from your local network logs onto the website to, you know, make a blog post or something and gets hit with an XSS vulnerability. The hacker's inside your network now. It doesn't matter how good your firewall is because you've just given them front door access. Preventing script injection attacks isn't easy, but it's not impossible. There are a lot of great libraries and standard functions included in a lot of your favorite programming languages like PHP that will do a lot of this work for you. So you don't even really have to think about it. And chances are whoever's writing these library functions has devoted a lot more time and effort to preventing these attacks than you will. So don't reinvent the wheel and use someone else's hard work and use some of your language's built-in defenses against cross-site scripting. Finally, or additionally, any reasonable mitigation strategy must employ defense in depth. One layer, no matter how strong it is never sufficient. You can have the world's best web application firewall, and it just takes one tiny flaw in that web app firewall for it to become not part of the equation anymore. I'll just say, I've done a little bit of research into web app firewall bypassing. I'm not going to get into that today, but don't count on them. They're not a stop-all. Additionally, having an application that you think is very secure is not an effective mitigation in and of itself either. You could be the world's best coder, and there could be a completely new technique for exploitation discovered tomorrow that no one had ever thought of before. And unless you're practicing defense in-depth strategies, you still might get owned. And there's this little quote that I kind of came up with. I don't know if anyone will catch the reference, but when you visit a website, you're not just trusting that website, but every other user who has ever visited the site. Yeah, I think Richard gets it, but maybe no one else does, which is fine. So, Q&A time. Anyone have any questions? Any comments? Did I just do like such an awesome job that everyone knows? And you're all going to go home and just like XSS people like that thing? Like, that thing is done for. I'm just going to wipe that when I'm done. You're XSSing it right now? I think you have to actually click the OK button before, yeah.
I feel so sorry for these
yeah,
videos.
there's probably a lot of those on there. Oh, there we go. So they're all executing serial, which is unfortunate. So I think we've just gone into an So, anyone, any questions?
Can I Google that for you?
Okay, well, that's all I have. So if no one has any questions, you're free to go or stay or whatever.
Oh wait, Manuel, do you have anything?
Oh yeah, do we have any announcements?
This Friday, we're going to meet to plan our hackathon, which is on November the 2nd. So if you want to participate on that, we'll have posters and things up in a sign-up form for you to participate soon, probably by next week. We are redoing our cloud. So if you want to get involved, learn some networking, learn about virtualization, all that kind of stuff, stop by our office next Wednesday I'll send out an email if you want to get involved. It'll be easy to do so. Also, I'm not 100% certain, but we might have assistant officer elections. I'll also let you know about that in the email. That should be it for logistics, I think.
Okay. One more round of applause for the first guy to get the successful exploit. I think that was. Source code.